Alright, today I'm showing off this Blackjack demo I made using C++ and OpenGL. So we can see here we have a screen on this side, and we have a card and ace, and we have a console on the side. So we can type either H to hit or S to stand. Let's hit, and hit again. So we're at 13, I'll hit one more time, 18, I'll stand. And then the dealer plays, they flipped a 2, a queen, an ace, and 9. They got 22 and bust, and it says we won. We can type P to play again. So we got 4, then a queen. We'll hit one more time. And a stand. Alright, the dealer won. So we'll play again. Hit, stand, dealer won. Alright, we won that time because the dealer bust. And if we want to, we can completely play this in a full screen mode with just this. You just have to kind of keep track of numbers in your head yourself. So 7, 17, we can stand. So the dealer got 26, so we won. So we can play again. Hit, 17, I'll stand. The dealer got 19, so we lost. So we can play again. 20, stand, we won. And if we push escape, we can exit out. So you can't play completely without the console. I was looking at how to do text in OpenGL, and it's a little complicated, so I just decided to keep the console for like deciding who wins and keeping track of the numbers. But let's explain how this works. So up at the top here, we create a camera using our camera class. It's a file that lets you create a camera. And then we create a screen, or we just set the width and the height for a screen. We keep track of a number of aces. We forward declare the game, a bunch of card positions. So this basically, each one is just slightly further up, or no, slightly further down, and slightly further towards the camera. So that gives the stacking effect that you can see here. So like each of these is slightly down and slightly towards the camera. And then we have an equal value, which I'll explain later. And then so we have a card class. It can print itself. It stores its suit and its rank. It can return its value for the game itself, or it can return its get PNG location. Then you have an array of cards of 52, and this is the deck. And then we have our game. So in our game, we have the player score, the dealer score, the phase of the game, and a seed. And we have a deck location. So we have a function start game. We basically just set all those values to 0. We set equal value to 0. We shuffle the deck using the seed that we get based on the time. Then for each, we run through the entire list of card positions, and for each of them we reset them to what their base value would be. And then we run the setup deck textures, which is down later, and then we play the first card of Blackjack. And we have this game loop, which in the rendering calls will explain how it runs every frame. And it's kind of complicated, but basically, if the phase of the game is 1, so this phase is 0 is your turn, 1 is the dealer's turn, then 2 is the phase that determines who won, and then 3 is the phase waiting for the player to either escape or push play again. So if it's the dealer's turn, the dealer will just play Blackjack, which will explain the function down. Otherwise, if it's phase 2, we'll either say you won, the dealer won, or it's a tie, and we'll move to phase 3. And then otherwise, so if it's phase 1, and the last input wasn't empty, so we put an input, and you've taken a turn, which is part of the input function, just to make sure you don't spam it, then we check if you typed H. If you typed H, we played Blackjack. Otherwise, if you typed S, we run this function here, which basically it takes the card positions and moves them over to the other side of the screen, and it does this by setting equal value to the last card that you played, and then each card after that is flipped to the other side of the screen and then subtracts equal values Y and Z, and then we play S Blackjack S. So this means we stand, and then I'll show what that does. And lastly, if we type P and it's phase of the game 3, we restart the game and we clear the screen. And then down here for play Blackjack, it's pretty simple. If we typed S, we reset equal value, which is that thing that moves the cards. We say you stood, and then we move the phase of the game on. Otherwise, if it's not this and we returned, so if we didn't type S, if we typed H or something else, I guess, but that wouldn't be able to get through, we set this, we create a score variable. If it's the player, we set it equal to player score. If it's a dealer, we set it equal to dealer score. We add the next card on top of the deck to its value. If it's a ace, we add 11 and increase number of aces. And if the score over goes above 21, but we have an ace, we subtract 10 and remove an ace. So this is how we do aces being 10s and 1s. Then if it's a player, we say you are dealt. Otherwise, they say dealer is dealt. We add 1 to the deck location, which is like flipping the card over so you get to the next card. Then if the score is 21, we basically just say you bust, and we reset, and then we move the deck location so that it appears on the dealer screen. And then if it's X, which is like the first turn, we just print this little message. And if it's not the player and it's the dealer, we don't ask for inputs. We just say if it's greater than or equal to 17, we stop playing. Otherwise, we keep playing. Then we have some basic functions here. This is our input function. Basically, each input, P, S, and H, all have 2 1s. They have a release and a press. If we release it, then it sets H press to true. And if S press is true, then S press is set to false. Last input is set to S, and taken turn is equal to true. This is just the code to stop it. If you hold down H, you don't keep playing like a ton of times. Then this is our main file. We just set up OpenGL, create a window, make it the current context, set up GLAD, create a shader. We got our 2 shader programs here. Then we create a vertices or a float that creates basically a card shape. And then we create a vertical array object and a vertical buffer object so that we can send position and texture data from here into our vertex shader like this, and then it goes to the fragment shader to render a texture. And then in our render loop, we clear the screen, make it little green, use our shader, set up the camera with a projection of you and a model down here. And then for each, if we start at 0, and for each deck location, so like whatever deck location we've gotten to, we draw each card in there, and then we process input, we run the game loop, and then we swap buffers, pull events. And if after we've gotten through that, we terminate. And then finally, the setup deck textures, which is that function that was called at the beginning. This basically just takes the first 16 deck value, like the first 16 cards in the deck, and we generate a texture for them. And then we have some debugging down here, and then we set it to our shader. And if we look at our fragment shader, we take in 2 values. We take in an array of 16 textures, and we take in selected textures, which is an integer. And we basically say, whatever this integer is, find that in the array of textures. So if we go up here, when we're drawing it, we set integer selected texture to I. So this means when we draw the entire deck of cards, for each card, it looks at what place it was, and then it draws that texture from the deck. All right, and that is how the game works. I hope you enjoyed the video, and if you want to learn more in depth about some of these processes and an earlier prototype of this, you should click on this video here where I make Blackjack, but I haven't fully added all the rendering in yet, so you can see what this project looked like before. Until next time, see ya!